Welcome to the next video. In this video and in the next videos, I want to talk about type annotations in Python. Type annotations can be used to express your intention of a function or a method, for example, what types are allowed for a parameter, for example. So I'm here on the official documentation of Python in the typing module. And here we have a little example of a function that is called greeting. This function has one parameter, which is called name. And here it is type annotated with a string. So we have a parameter name, then a column, and then the type that the variable should take. However, you can pass in this function an argument, for example, of a type float. But then the code might not work. So type annotations are more kind of a documentation than of a strict type that the variable has to be. So in Python, there are no strict types for any variable, as you know. And type annotation doesn't change this behavior. This type annotation here just says, okay, this function should take a string, because only then the implementation will do what the programmer intended. So this type annotation here just says the programmer of this function expected that every argument that is passed in later on in this function should be a string, because only then the function will do what the function should do. However, we can still pass in integers or floats, for example. But then the function would have an exception here, because we would add a string with a float and this wouldn't work. So this addition here would only work if name is also a string, then we would concatenate these two strings. So type annotations are more kind of another documentation part than a strict type expression. Also, I can annotate the return type of the function, since we are here adding two strings, which is a concatenation. The result would be also a string that is returned here. So we return the result of this addition here, which is also a string. So the return type is a string, and the return type can be expressed here after the closing parentheses with a dash greater sign, which indicates an arrow. And here we can list, okay, the return type should be also a string. So this is the short introduction to type annotations, and you can define your own types that we will see also in the next videos. For example, here we can use type aliases, where we can say, okay, a list that consists of float, I can do a type alias for this, and I will call this vector. So whenever I type annotate any parameter here, for example in the scale function with the vector type, under the hood, this vector type is a list of floats, for example. Also, this function would return a vector, so the return type is a list of floats, for example. Furthermore, you can type annotate, for example, parameters that should be a sequence. So the parameter is iterable, for example, and so on. So you can do a lot of things here with a standard typing module. And at first, I want to show you our vector2d class that I have type annotated right now. I will go step by step through this file, and in the next videos, I will show you type annotations with other functions. So here I'm in our vector2d class, and for example, in our dunder init method here, we had the two parameters x and y. In the last videos, I set the default value, for example, equal to 0 or equal to 0.0. So either it was an int or a float, for example. And we could use here a supports float type, which would lie in the typing module. So the typing module is the module in the standard library that contains a lot of abstract base classes, so abstract types that can be annotated here. So for example, the support floats would work if you pass in an integer or if you pass in a float value, for example. So if a function doesn't return anything, we can also type annotate this by the arrow here, and then we can type here none. Because per default, as you might know, Python functions always return none if the function hasn't a explicit return statement. So our dunder init method hasn't a return statement, as we can see here. So the default return value is none. And to make it explicit here that everybody sees directly, okay, we doesn't return anything here, I directly see here, okay, the return value is none. For functions where we return something, so here, for example, in the dunder call method, we return the return value of the representation function of the class. I could see, okay, the return value of the representation function here is a string, since we are returning here a string. So the return value of the dunder call method is also a string. And in the following, I will show you a tool in the next videos that is called Mypy that can check your code based on the type annotations to find errors in your code, or inconsistencies at least. So if I go a bit further, for example, to the apps function here, or to the dunder apps method, I use here the square root function of the standard library. And the standard library has also type annotations. And I see here, if I hover over with my mouse on the function, that the return value of the function is a float. And since we are returning the value that is returned by the square root function, the return type of this method is also a float. Yeah. So Mypy would check, okay, you have written here the return type is an integer, but the return type of the square root function is a float, and now Mypy would argue here, incompatible return type value got float expected int. So Mypy would now found an issue here in our code. So to show it exactly, we can run Mypy in the terminal. I just call Mypy and then the file vector type annotations.py, and now I see here the error in line 72 as I showed here, and we see we have an incompatible return type value. So now I would see, okay, something in this function is wrong, and then I would see, okay, the return type must be here float. So if I rerun Mypy now, we have no warnings left, and yeah, Mypy succeeded the checks. So no issues found in one source file. If I go a bit further, for example, let me see here, I have the dunder add method where I can add two vectors, and you might know if you add two vectors, a new vector should be returned. So here the return type is, for example, the class itself, and the parameter here is also an instance of the class itself. So you can pretty much type annotate every parameter that we have here in our dunder, that we have here in our methods, but you do not have to type annotate the self parameter, since the self parameter in a method is always an instance of the class itself, and the type annotation tools like Mypy are smart enough to see that self has to be a vector 2D instance, for example. So here's one more pretty nice feature of the typing module. If a parameter can have or can be of several types, you can use a union, and a union is just a list of types that are allowed. So any of these types here in the union list are allowed. So the other parameter can be either a supports float, which is also a union of float and integer, or it can be a vector 2D. So if the passed in argument is any of these two types, Mypy wouldn't complain. If you would pass in here a string, for example, Mypy would see, okay, supports float and vector 2D are the only allowed types, but you passed in a string, and then Mypy would just put out a warning or an error here in the command line, for example. So in the next videos, I will go through what a union is and through many base types that are here defined in the typing module. And yeah, we will see us in the next video. Bye bye.